Okay, we have here today a quick integral from the Scranton integration bee from 2015. This was finals number 5. We have the integral of arctan of 1 over x dx. Okay, now the way we handle this, if this was just arctan of x, is just integration by parts. We have a little variation here because we've got 1 over x as the output. But I think I'm not even going to worry about that right now. Let's just go right to integration by parts, just as if it was arctan of x. So what I'll do is we'll do the DI method or tabular integration. We'll create 2 columns. We only have one thing here, so I can create a 1 so that I can integrate 1, and we'll differentiate arctan of 1 over x because we don't really know how to integrate that. And then we'll just go ahead and we'll differentiate this. So the derivative of arctan of 1 over x, we know the derivative of arctan of x is 1 over x squared plus 1. So first we're going to have 1 over x squared plus 1. But then we need the chain rule, take the derivative of 1 over x. That's going to be minus, I'll write this over here, I'll write it as minus 1 over x squared. And then over here, we'll just integrate 1 and we get an x. So then we'll have part of our solution on the diagonal. Let's just write that part down. So we're going to have x arctan 1 over x. Now, all this here is going to be an integral, but let's clean it up a little bit before we do this because it's kind of a mess the way it is right now. Now, first of all, we're going to have minus and minus, so I'm going to change those to pluses. And then, I'm going to distribute this in, but then this is going to go into the numerator. So we'll put it over here. So when we put together this integral, I'm going to have x in the numerator, then distributing in x squared times 1 over x squared. I can put this like this, 1 over x squared. So x squared times 1 over x squared just gives me a 1. And then x squared times 1, so this is going to be a plus x squared. But now this integral really isn't too bad because I can do a u substitution on this over here. I'll just make my u the whole denominator. So we'll say u equal to 1 plus x squared. I'll take a derivative. Derivative of 1, 0. Derivative here is going to be 2x dx. I can just create the 2 right here if I multiply by a half out front. So I'm just multiplying by 1. And by doing that, what we have here, this is exactly the same as our du value. So let me actually just do this whole integral off to the side here. So I'm just rewriting it like this. And then so when we substitute here, again, we're going to have just du. And everything in the denominator is just going to be u. So integrating this, we're just going to have half natural log absolute value of u. And so now we can just back substitute in order to finish this off. So we'll bring our answer up here. We need to copy down this first part. So we have x arctan 1 over x. And the rest of it's going to be, we're going to have 1/2 here, natural log, and then the back substitution, this is going to become just x squared plus 1. Good. But because x is squared, this is always positive. So we'll just remove absolute value sign on this, add a plus c, and that's it. Okay, so there you have it. Pretty straightforward integral from Scranton Integration Bee 2015. Thanks everyone for watching. Have a good day.